Hello, this is the sixth video about matrices, inverse of a matrix. In the last video, we learned transpose and determinants of matrices. Now, let's get started to our new topic. The inverse of a number is when you make it upside down. For example, if we have the number 7, its inverse would be 1 over 7. If our number is 4 over 5, its inverse will be 5 over 4. One of the most important characteristics of an inverse is that when you multiply it by its original, you always return to the number 1. Inverses are extremely useful when you are working with the complicated calculations. Here we have this. This can be a lot easier to read if you simply use an inverse. When you are calculating with matrices, you won't be able to divide it all. So you need to rather multiply by the matrix's inverse. If you want to calculate a matrix by hand, it will be difficult, but it is possible to calculate by hand. You need to apply the characteristics of an inverse that by multiplying an inverse by its original, you will get back the number 1 for a single value, or the identity matrix, if you are working with matrices. So, let's get started with the example. This is matrix A. Now, we need an inverse that will be the 3 by 3 identity matrix, which is I, after multiplying the original matrix. To set this up, it helps to put two together. So, if I create a double white matrix and put the identity matrix on the other side, this will help me perform the calculations to produce the inverse of this matrix. Now, to calculate this, you have to complete the calculations on each row of this matrix. To make the left-hand side turn into the identity matrix that's currently on the right. This situation is somewhat simple since these rows are pretty close in number. So to start with, I am going to change row number 2. So for row number 2, I am going to alter that by subtracting row 1 from it. So if I go down here and I still have row number 1 the same and row number 3 the same, except row number 2 is now 0. And then 4 minus 3 is 1. 3 minus 3 is 0. That becomes a negative 1. That remains 1. And that remains 0. I can change row number by doing the same thing that I just did to row number 2. I am just going to erase what's currently on in the row number 3. And row number 3 minus row number 1. So that becomes a 0. A 0 and a 1. Now finally I need to change the first row because I have these bottom 2 rows on the left side, the same as the identity matrix was previously. So to keep change the first row, first I am going to subtract 3 times the second row. I am going to keep my second and third row the same. So 0 times negative 3 is still 0. So that remains a 1. Then this becomes a 0 because I'm subtracting negative 3 from it. And that remains a 3. Negative 3 times negative 1 is 3. That becomes 4. That becomes a negative 3 and this remains a 0. Now I need to do the same thing with row number 3. So I need to multiply row number 3 by negative 3 and then subtract row number 1 from it. So that becomes a 1. That stays 0 and this negative 3 from 3 is 0. And now here 4 plus 3 is 7. That remains a negative 3 and that becomes a negative 3. Now, this right here, this matrix, That's 7, negative 3, negative 3, negative 1, 1, 0, negative 1, 0, 1. This is the inverse of my original matrix. A. One way to test this is to multiply A times A's inverse, and see if we get back the identity matrix. Now, if we step through this for the first spot here, we multiply the first row here times the first column. So 7 minus 3 becomes 1, and then negative 3 plus 3 is 0, and then negative 3 plus 0 plus 3 is 0. The second row is 7 minus 4 minus 3, that's 0. Negative 3 plus 4 is 1. And then negative 3 plus 0 plus 3 is 0. Negative 7 minus 3 minus 4 is 0. Negative 3 plus 3 plus 0 is 0. And then negative 3 plus 0 plus 4 is 1. And we returned our identity matrix. So this has been confirmed to be the inverse of this matrix here. So essentially, what we did here is we may have multiplied A by its inverse. You can also think of this as us having divided A by itself. So later on, when you are working with matrices and you need to divide the two matrices, don't forget the inverse. Because if I had a matrix P that I had to divide A into, I will instead do B inverse of A. This was the sixth video about matrices, and our topic was inverse of a matrix. I hope you liked the video. Thanks for watching.